Beijing soldiers march with brand new pistols, gleaming in parade formation. A display of modern power. But under that polished image lies a gamble no army can afford. A sidearm can seize up with a single handful of mud. On paper, the Chinese QSZ-92 matches Western specs and looks flawless. In battle, its one flaw can mean the difference between life and death. Why would China choose precision engineering that works against them in the field, while the US M17 is built for chaos, firing even while drenched or packed in sludge? The answer is not just about guns. It is about how nations measure strength and the hidden test every soldier faces when the world turns to mud. Rows of soldiers move in perfect rhythm, boots striking the pavement in unison. Every holster carries a QSZ-92, its polymer frame catching the light, its lines echoing the world's most advanced sidearms. Cameras linger on the pistols during the 2019 National Day Parade. Each weapon is a symbol of China's promise to match Western power, not just in numbers, but in technology. The scene is flawless. Uniforms immaculate, pistols gleaming, the choreography as precise as a metronome. State media broadcast these images around the world, inviting comparison to any Western army. On paper, the QSZ-92 boasts a high-capacity magazine, a modern polymer frame, and a unique 5.8mm round. The message is clear: China's infantry stands shoulder to shoulder with the best. But perfection on a parade ground is only skin deep. Behind the spectacle, a question lingers. What happens when the rain turns the field to mud? When the clean lines of engineering meet the chaos of real war? The answer hides beneath the surface, waiting for the first drop of grit. 20 rounds of 5.8mm armor-piercing ammunition sit stacked in the QSZ-92's magazine, more than most NATO pistols offer. The polymer frame keeps weight down and promises comfort on long patrols. On a technical sheet, the numbers line up with Western designs: high capacity, modern materials, double-action trigger. But none of these metrics account for the grit that sneaks beneath the slide or the mud that clogs moving parts. The QSZ-92's reputation for precision is built in laboratories where every round is clean and every function flawless. In those conditions, the failure rate is less than 2 per 1,000 shots. Yet the battlefield is not a laboratory. A rainstorm, a ditch, a single slip into a rice paddy, and suddenly the perfect pistol is full of debris. The difference between life and death comes down to whether a sidearm can shrug off that chaos. In the hands of a soldier crawling through mud, a gun that jams once is a gun that fails completely. The QSZ-92's promise of precision becomes a question mark the moment the first grain of sand gets inside. Inside the QSZ-92, the cycle begins as the slide drives backward under recoil. Unlike most Western pistols, the Chinese design relies on a rotating barrel to unlock the action. As the slide and barrel move together for a short distance, a set of cam lugs engages, and a helical groove forces the barrel to rotate roughly 20 to 30 degrees. This precise angular movement is not a side effect. It is the core of the mechanism. The barrel's locking lugs must align perfectly with the matching recesses in the slide. Only when the barrel completes this rotation does the slide break free to continue cycling, ejecting the spent case and feeding a new round. On a clean range, this choreography is smooth. The fit between the lugs and recesses is tight, engineered for minimal play. The rotation angle, just enough to unlock, not enough to cause drag, keeps the system efficient. But this efficiency comes with a price. Every degree of rotation depends on clean, uninterrupted movement between metal surfaces. The moment debris enters the equation, the system faces a new challenge: rotational friction. Grit or mud between the lugs does not just slow the process, it can halt it entirely. The barrel tries to turn, but resistance builds. The slide stalls, the cycle stops. This vulnerability is unique to rotating barrel systems. In a tilting barrel design, the movement is mostly linear, up and down, and is less likely to bind. Here, the QSZ-92's precision becomes a liability. The mechanism demands that the barrel rotate the full 20 to 30 degrees every time, or the gun will not fire again. Lug-to-lug alignment must be flawless, even when the weapon is caked in mud. The more precise the fit, the less margin there is for error. When the parade ground turns to swamp, the smallest grain of sand can transform a technical advantage into a fatal flaw. A rotating barrel is elegant in theory. The helical grooves and cam lugs of the US-M17 promise smooth cycling and softer recoil, as if the gun were built for a marksman's podium, not a foxhole. But the moment mud or sand enters the mechanism, the flaw becomes physical. Rotational friction is not a distant engineering concept. It is the same stubborn force that locks a rusted screw in place. When grit fills the space between the barrel's locking lugs and the slide's recesses, the barrel cannot turn. The slide is trapped. The gun is frozen. No amount of training or discipline can force a jammed barrel to rotate through a slurry of clay and sand. This is not a new lesson. In the early 20th century, European armies experimented with rotating barrel pistols, like the Steyr M1912 and the Roth Steyr M1907. Both were celebrated for their craftsmanship and accuracy. Both fell out of favor as soon as the realities of trench warfare exposed the limits of angular lockup. Mud, blood, and debris found their way into every crevice. Soldiers needed a sidearm that would function after being dragged through a trench, not just after a parade inspection. By the end of World War I, militaries around the world turned to tilting barrel designs. The American M1911, the Browning High Power, and later the Glock all used a simple up and down motion to unlock the slide. Linear movement tolerates grit. Angular movement binds and fails. Civilian pistols like the Beretta PX-4 Storm kept the rotating barrel alive for range and police work, where clean conditions and recoil control matter more than all-weather reliability. But in the hands of a soldier, the screw-in-sand problem is not theoretical. It is the reason armies abandoned rotation for combat pistols. The QS-Z92 revives a mechanism history left behind, betting on precision at the cost of survival in the field. The lesson is clear. War punishes complexity. Simplicity endures. Every time the M17 cycles, the barrel does not twist or hesitate, it tilts. The motion is abrupt, direct, and brutally simple. When the slide recoils, the barrel drops out of lock with a single forceful pivot. There is no delicate dance of lugs searching for the perfect rotation. Instead, the up and down movement drives through debris, pushing aside grit that would stop a rotating system cold. The tilting barrel design is not elegant, but it is relentless. It is the same principle that kept the M1911 running in the mud of Flanders and the sands of Iwo Jima. Linear force wins in the real world. The secret to the M17's resilience is not just in its motion, it is in its heart. At the center sits the Fire Control Unit, a stainless steel chassis that houses every critical component: the trigger, sear, springs, and rails. This is the serialized core of the weapon. Everything else, the grip, the slide, even the barrel, attaches to this module. If the polymer grip cracks after a drop or a blast, it is not the end of the weapon. A soldier can strip the pistol, lift the FCU out, and drop it into a new grip in under 30 seconds. No special tools, no armorer required. The FCU is the weapon. The grip is just a shell. This modularity is not a marketing gimmick. It is the result of digital engineering from the ground up. Sig Sauer's manufacturing lines use computer-controlled machining to cut each FCU to precise tolerances so that every chassis is interchangeable, whether it is the first off the line or the 500,000th. The Army's requirement was clear: a weapon that could be rebuilt in the field and restored to full strength before the next patrol. The M17 delivers that promise. In the hands of a soldier, it is not just a pistol, it is a platform built to survive whatever the world throws at it. Every M17 begins as a digital file, a three-dimensional model mapped to the micron before a single part is cut. On the factory floor, robotic arms and CNC mills translate these blueprints into steel and polymer. The heart of the weapon, the Fire Control Unit, is shaped from stainless steel with tolerances so tight that any fire control unit can drop into any grip any slide, and function as if they were born together. This is not just manufacturing, it is industrial choreography, repeated 500,000 times without deviation. The grip module, the part a soldier holds, is made from injection-molded polymer. It is not precious, it is not even expensive. In civilian markets, a replacement grip costs $50 to $100, depending on the model. For the military, these grips are stocked by the thousands and ready to be swapped in the field. If a grip cracks, the core weapon remains intact. The fire control unit is lifted out, the damaged shell discarded, and a new grip clicks into place in under a minute. There is no need for an armorer, no downtime waiting for parts. The serialized chassis is the firearm. Everything else is a replaceable skin. This architecture is built for scale. SIG or DA. Production lines run on digital feedback loops. Each fire control unit checked by automated sensors, every dimension logged and compared to the master file. The Army requirement was not just for reliability in the mud, but for interchangeability at scale. The result is over 500,000 M17s and M18s delivered, each one as precise as the last. This is the same philosophy that drives America's aerospace industry, the B-21 bomber digital twin now applied to a soldier's sidearm. The M17 is not just a pistol, it is a platform designed for the realities of war and the demands of mass production. When a weapon can be rebuilt on the battlefield in seconds, the soldier is never out of the fight. A test engineer stands over two pistols, each packed with thick, wet clay. The QSZ-92 and the M17 are buried side by side. Not a gentle drop, but a shove into mud that fills every crevice. The armorer's gloved hands press the muck into the slides, around the triggers, deep into the barrels. There is no cleaning, no mercy. Both weapons are loaded. The engineer lifts the QSZ-92 first, racks the slide, and pulls the trigger. The hammer falls, but nothing happens. The slide is stuck halfway, jammed by a slurry of clay wedged between the barrel's locking lugs. The engineer tries to rack it again. The barrel will not rotate. Each attempt is met with grinding resistance. The spent round sits in the chamber, half extracted, the slide frozen in place, a classic stovepipe. Seconds pass. In a firefight, that is a lifetime. Now the M17, the same mud, the same treatment. The armorer racks the slide. It is stiff, but the motion is direct, linear, not rotational. The barrel tilts, forcing the mud aside. The engineer pulls the trigger. The striker's spring unleashes its energy, smashing through the primer even as water and grit cling to the firing pin channel. The round fires, the slide cycles, ejected brass spins into the mud. Another round feeds. The engineer squeezes off 3 more shots. Each time the barrel's violent tilt and the force of the striker overcome the hydraulic drag of the mud. The M17 keeps running. The difference is not luck, it is physics. Rotational friction traps the QSZ-92 in a death grip, while the M17's tilting barrel and sealed striker channel create a hydraulic bypass. The striker's kinetic energy is enough to drive through water, mud, even the resistance of a flooded firing pin cavity. In this trial, the gap is absolute. One pistol fails, the other ignores the elements and fires again. This is not a debate, it is a demonstration. More than 500,000 M17 and M18 pistols are already in the hands of American soldiers, Marines, and airmen. This is not a boutique project or a limited rollout. It is a logistical achievement on the scale of a national highway system. Every unit, every armory, every forward base supplied from the same digital blueprint. The serialized fire control unit at the heart of each weapon means that spare parts, replacement grips, and slides are fully interchangeable, no matter where the pistol was assembled or who is carrying it. If a grip module cracks in the field, a replacement is snapped on in less than a minute. The core weapon, the FCU, keeps firing. This is not just about convenience, it is about operational uptime. Every pistol can be rebuilt as quickly as it can be stripped, with no reliance on specialized tools or depot-level maintenance. Ammunition feeds this system with the same industrial discipline. The M17 runs on M152 ball and M17 special-purpose rounds, ammunition produced to exacting standards, batch after batch, by American manufacturers with decades of experience. Each cartridge is identical, each primer reliable, each powder charge measured by machines tuned to fractions of a gram. The result is a supply chain that delivers not just quantity, but consistency. Every soldier pulling the trigger can trust that the round will fire, cycle, and eject, whether a soldier is on the firing line at Fort Benning or in a rain-soaked trench overseas. China's standardization story is different. The QSZ-92 has seen updates and variants, QSZ-92G and QSZ-92A, each promising incremental improvements but complicating logistics. Spare parts must match the exact model, and upgrades often require entire batches to be cycled out of service. There is no evidence of a single modular chassis uniting every pistol in the field. When a component fails, downtime stretches from minutes to weeks, and the guarantee of interchangeability fades. Scale in the American model means more than numbers. It means a system that endures, adapts, and keeps its users armed and ready. When the test ends and the mud is washed away, the true measure of a weapon is not just how it fires, but how it stays in the fight. Right now, over 500,000 US soldiers trust a weapon designed to survive the worst the world can throw at it. As great power competition returns, reliability is not just an engineering metric, it is a matter of life or death. In the end, the sidearm that endures chaos shapes who walks away. The battlefield still rewards those who build for reality, not for show. What do you think matters most in a fight?